Hey, yes, you in the gray. Yes, sir. What's your question?
Can you give a brief description of some challenges you faced with the data logger and, just some challenges you had?
Interesting question. Great one, by the way. Well, the challenge of this project was to prototype and build an Arduino board that measures temperature and light throughout the surrounding environment. The purpose of this project was to problem solve using our own skills and knowledge to create an independently operating environmental sensor that is the basic version of what we might use in our future careers. First, we used an online tool about electrical components and programming and created an Arduino sensor from scratch. Next, we built the sensors using the breadboard and finally the Arduino to test our components. Lastly, we soldered, desoldered, soldered, desoldered, and create our independently working data logger of temperature and light cycle.
Yeah, you over there.
What about giving a brief description of the environment? Both locations that you decided to monitor and why you chose those two? And do you happen to have any visuals? Because I'm a visual learner, so all these words, they're really just, not working for me.
So both locations that were the focus of the data collection were inside Gregory Gym. The first data set was taken on the top floor of Greg, on the indoor track next to the window, while the second data set was collected inside the fridge located in Shakespeare, at the front of Greg. We chose to collect data at Greg primarily because we wanted a centralized location on campus to be able to meet before and after classes, simply because it's difficult to align three busy schedules. And we also wanted contrasting data, so we thought Greg would be one of the more warm buildings on campus from all the people working out and moving around. Well, the fridge would provide the coolest environment in the building simply because it is a fridge. Data that was recorded for the track was inconsistent for the most part, which was expected because the Arduino was not moved once the measurements were being taken. The measurements for the fridge were dropping throughout the data collection process till it found an equilibrium at about 64 degrees Fahrenheit. The actual fridge showed that it was 44 degrees, but since this was an open fridge unit, the actual temperature inside was not 44 degrees, and it could therefore be rationalized that the temperature sensor that was used was readily accurate. We ultimately saw a 10 degrees difference in the locations that were chosen for this project because the track was warmer, due to runners occupying the area and the fridge was working properly using a cooling system, thus providing a cooler environment. The temperature sensor in the fridge took longer to reach a point of equilibrium simply because it had to adjust to a temperature that was much lower than the surrounding area. Thank you. Next question.
Yeah, over there. Yeah.
Thank you, sir. So, can you explain the process the team went through to build the data logger? Did the process go smoothly, or were there roadblocks encountered that had to be overcome? Which parts of the process did you find most challenging, and what were the main pitfalls? What differences did you see between the two locations, and what similarities? And discuss each of these things.
Yeah, that's a good one, for sure. I think we all worked pretty well to help create the data logger. What do y'all think? Everyone working with their strengths, whether that be soldering or programming or even 3D printing, in order to create the best project possible. Overall, the team had a couple setbacks for sure. Pretty much all dealing with soldering. We ran into issues with our sensors not producing any data, our temperature sensor being affected by light, so on and so forth. However, there was definitely soldering needed to be changed, and it messed with the format of the board and matching it with that was on canvas, which we should have done in the first place. For sure, desoldering and soldering about 3 times proved to be definitely a difficult task, but after days of work, we were finally able to actually complete the data logger you see before you. Oh yeah.
Yeah, look, will you assess your final product? I want some pros and cons of your finished design. What steps would you change,
Okay. The pros of the final project is that the Arduino itself is clean and organized. fast, and it has a, if I say so myself, a beautifully 3D printed box. Overall, the better prototype would be if there was a completely like different colored wires just for organization for every different connection. And the 3D printed box isn't totally perfect, which, thank you.
It's beautiful.
It's beautiful.
We can refine that for sure. And some dimensions are lacking, especially for the insertion of the XD card later on. But we're confident that our sensor is able to work and will be able to work independently with the implementation of the SD card port and the battery port and other measures that we have to take. Thank you.
And you. Okay. Yes, that's your question.
List 2 main challenges you faced in this project, and if you were satisfied in the way you addressed these issues. You know, tell me your favorite part of the project and what you didn't like about it as well.
Well, there were definitely some challenges that we faced in this project. The biggest challenges were the physical soldering of the project, like we have mentioned time and time again. With the finicky sensors that wouldn't work and the soldering that just wasn't getting perfect for us. Sometimes the actual coding would not upload to the Arduino for some reason and start collecting the data, and the SD card didn't record values. Sometimes the light sensor would work, but the temperature sensor would not, so it was a lot of finicky details that were really putting us back, like setback after setback, even though we were trying to go forward in our steps. Overall, we had to solder and Overall, the main issues were that there was something wrong with the circuit and connections every time because the temperature sensor was reading values that were reliant on the light sensor and when it shouldn't have been, so that's why we really had to resolder and desolder several times because the connections weren't right in the circuit board, which was causing us our main issue. We wanted to be able to create an independently working and reliable sensor. And over our second desoldering and third resoldering, our sensors were reading independently from each other. We could finally start the project. Now, the worst part of this project was not only the resoldering and desoldering, but was the finickiness of the sensors. Because they're so cheap, they were easy to purchase, and that means that they weren't necessarily reliable sensors, which was giving us a lot of issues. We said that overall we would pay for slightly more expensive sensors next time because we wouldn't have to go through hours and hours of desoldering and resoldering, even if we had just finicky sensors to begin with. Because it's a lot of valuable times that we have as students, everyone's busy. So those are hours that we value, especially when it's not convenient, when the invention workspaces is open for us. So it really puts a lot of time out of our schedules. The best part of this project was ultimately the interface is user-friendly, and being exposed to more of the electrical engineering field was really interesting for all 3 of us to be exposed to and learn. And knowing the field is accessible even to those who have no previous knowledge in it. Thank you for your question.
Thank you, everyone.
Yeah, we're kind of
Thank you.
pressed for time right now.
We actually need to go.
Yeah.
So thank you for
Much
coming.
love.
Yeah,
Much love.